Right, solving equations, part 3. Here's our procedure for this lesson, at least for these first few problems. Step 1 is to simplify each side of the equation, and then we're going to use the properties of equality to solve the equation, just like we did on the previous video. Okay, here's our first example. If you watch part 2, then you know this is a little bit different because it has parentheses in the problem. So the first thing we need to do is get rid of the parentheses, distribute the 2. So use the distributive property to get rid of the parentheses. A times B plus C equals A times B plus A times C. So on the left side, distribute the 2, and on the right side, distribute the 3. Again, if you know how to do this or kind of have an idea, give it a shot. Pause the video and then work it out, and then come back when you're ready. Okay, so on the left side, we distribute the 2. So 2 times 5x is 10x, and 2 times negative 3 is negative 6. Do the same thing on the right-hand side. 3 times 4x is 12x, and 3 times negative 8 is negative 24. Now it looks like a problem on the last video. We need to get x on one side. I'm going to get x on the left-hand side, so subtract 12x on both sides. So 10x minus 12x is negative 2x. The signs are different. Keep the sign of the larger. Bring down the minus 6 and the minus 24. Now we want to get rid of the negative 6, so add 6 to both sides. Do the opposite. So on the left side we have negative 2x, and then on the right-hand side the signs are different, so subtract and keep the sign of the larger. And now we'll divide both sides by negative 2. That should give us positive 9. 2 negatives when you divide is a positive. Okay, so we had to clean it up a little bit, right? We had to distribute on the left-hand side to get rid of the parentheses, and distribute on the right-hand side. Oh, we're going to do a check this time. Okay, so remember when you do a check to replace the number into the original equation. So it already has parentheses. What you might want to do is change the parentheses to brackets. So this is how I wrote it. Or you could just make bigger parentheses around the 5 times 9 minus 3. But I chose to use brackets here. It's the same thing as parentheses, just to look different. All right, do what's inside the parentheses. Do what's inside the brackets. 5 times 9 is 45. And on the right-hand side, 4 times 9 is 36. Now we will continue to do what's inside the brackets on each side. 42 on the left side, 28 on the right side. And then multiply the 2 times 42 and the 3 times 28, and on both sides, you should get 84. So this one does check out. Okay, a little bit more involved. Now we're going to have to distribute the negative 4 on the left-hand side. So it's not a 4, it's a negative 4. On the right side, distribute the 3. Now the x that's in front of the minus 4 on the left side, that's just going to come down and stay in front of whatever we get from the distributing. And the minus 8x on the right-hand side, well, that's just going to come down as well after we distribute the 3. Okay, so on the left side, negative 4 times 1 is negative 4. And negative 4 times x is negative 4x. On the right-hand side, 3 times 2x is 6x. And 3 times 3 is 9. And then bring down the minus 8x, and the x that's in front of the minus 4, bring that down as well. Now our next step is to add like terms. So on the left-hand side, We have an x, that's a 1x. When there's no coefficient written, it's a 1. So a 1x and negative 4x, that's a negative 3x. And on the right-hand side, we have a 6x and a negative 8x. Remember, we're combining like terms, so you don't do the opposite. You only do the opposite when you're doing the same thing to both sides, or adding like terms. So on the right side, 6x minus 8x, that's going to be negative 2x. Okay, so on the left-hand side, we have negative 3x minus 4. And on the right-hand side, negative 2x plus 9. Now we're right back to where we were on the last video. Add 2x to both sides. That'll give me a negative 1x. If you want to just put negative x, that's also fine. Now add 4 to both sides. Last thing is to get rid of the negative in front of the x. So you could either divide by negative 1 or multiply both sides by negative 1. It's your choice. I chose to divide both sides by negative 1. That way the two negatives cancel. And we end up with x equals negative 13. And we don't have to do a check on this one. You can do the check. Okay, this one's a little bit more complicated. We have two sets of parentheses on the left-hand side, one set of parentheses on the right-hand side. We're going to have to distribute the 7 in the first set of parentheses, distribute the negative sign in the second set of parentheses, and distribute a 3 in the third set of parentheses. That negative sign, we may want to put a 1 after the negative sign. It makes it easier for many people, so let's do that. So 7 times x minus 2 minus 1 times 3x plus 4. You may want to pause the video and work it out on your own. Okay, distribute the 7, that gives us 7x minus 14. Distribute the negative 1, that's negative 3x minus 4. Negative 1 times positive 4 is negative 4, so we put a minus. On the right-hand side, we get 6x plus 3, and then bring down the minus 3. Now we could add like terms. A 7x and a minus 3x is positive 4x. And a negative 14 and a negative 4 is negative 18. And on the right-hand side, the 3's cancel. Okay, on this step, we could subtract 6x on both sides. But then we would have nothing left on the right-hand side. We would have to bring the constant back to the right-hand side. It would create an extra step. The best thing to do here is to subtract 4x on both sides. That leaves us with negative 18 equals positive 2x. Now divide by positive 2 on both sides. And that gives us an answer of x equals negative 9. Okay, here's one with decimals. There are ways of solving problems with decimals by clearing the decimals. You could probably use a calculator in this class, so I'm not going to worry about that. So we want to get x on one side. The same steps as we've done before. You could use your calculator, so subtract 7x, 0.7x on both sides, 0.7x. So on the left-hand side, 0.2 minus 0.7 is 0.5. If your calculator writes it as a fraction, you have a button on your calculator that has a SD on it with an arrow in between the S and the D. On the Casio, it's right above the delete button. So if you hit that, it'll change it to a decimal for you. Okay, so that button is quite useful. With using the shift, you could actually change mixed numbers to improper and vice versa, or to decimal. So that SD button is quite important. Okay, so you should get negative 0.5x plus 3.56 equals 1.2. Now subtract the 3.56 and then do that operation on your handy dandy calculator. Again, if it gives you a fraction, hit the SD button and it'll change it to a decimal for you. Okay, now divide both sides by negative 0.5 and you should get 4.72. Okay, so even if you have decimals, it's still the same steps, not to worry. Here we go. Fractional equations. This is going to be good. Our first step is to determine the LCM of the denominators. It'll then be called the LCD. So we find the LCD for the denominators. Then we're going to multiply all terms by the LCD. This is a cool step. What it does is it clears the denominators. It gets rid of the fractions. And in step 3, now we could solve the equation just the way we've been doing it. So we're going to get rid of the denominators. Sometimes people want to get the denominators to be the same. That's in a later section, a different topic. Here, we want to get rid of the denominators. Okay, here's our first problem. What is our LCD for the denominators? That's our first step. For 9 and 6, the LCD would be 18. Okay, so both 9 and 6 both go into 18. The LCD is in 3, that's a GCF, that's the greatest common factor. We're looking for the number that 9 and 6 both go into. So if you take multiples of 9, there's 9, 18, 27, 36, and then look at multiples of 6. You want to find the smallest one that they both go into. There's 6, 12, 18, and it's 18 that's the lowest common multiple. So now what we're going to do is we're going to multiply all the fractions by the LCD. Everybody will get the LCD. So you're just going to rewrite it and put an 18 next to each numerator. Okay, now you're going to clear the denominators. So you're going to reduce the 9 and 18, the 6 and 18. On the right hand side, the 9 and 18 and the 6 and 18. So we're canceling the denominators. So 9 goes into 18 twice, so you can cancel out the 9 and the 18, put a little 2 there. Same thing with the 6 and the 18. And now we're going to simplify that. So on the left side, it's 2 times 2a, that's going to be 4a. And then 3 times 1 is 3. Keep the minus sign in the middle. On the right hand side, it's 2 times a, which is 2a. And 3 times 1, which is 3. Keep the plus in the middle. And there you go. It looks like the problems we've been doing. Subtract 2a on both sides. Then divide by 2 on both sides. And we get an answer of a equals 3. Shoot, we're going to do a check. We won't do a check all the time. It takes so long. All right, so we're going to go to the original problem and replace the a with 3. So you can work out each side separately. Let's see, 2 times 3 is 6 ninths minus 1/6. Get a common denominator on each side. And you should get 9/18. They both reduce to 1/2, but you can stop there. As soon as you see it's the same number on both sides, you're done. So you might want to pause that and work out each side. I know it's a little bit of work. All right, here's our next problem. Fractions everywhere, right? The numerators are a little bit different. The numerators are binomials. They have 2 terms. We're still going to find the LCD. What is our LCD? Our LCD is 12, right? 12, 3, and 2. All those numbers go into 12. If you make a mistake like using 24 for an LCD, it'll still work. It'll just have bigger numbers and more reducing at the end. So if you use a number that's too big, it's not really a problem. But 12 is our LCD. So everybody gets a 12. Now we're going to reduce. Okay, so on the first fraction, the 12's cancel, and we're just left with 3x plus 4. And then a 4 times 1 on the left-hand side. On the right-hand side, the 12's cancel in the first fraction, so just 5x plus 2, and then 6 times 1 in the second fraction. Now add like terms. On the left-hand side, the 4's cancel. On the right-hand side, 2 minus 6 is negative 4. Now we want x on one side. We want to bring the 5x to the left-hand side, so subtract 5x on both sides. That gives us negative 2x equals negative 4. And divide both sides by negative 2. So x equals 2. Okay, here's our next problem. Very similar to the last problem. What is our LCD for 4, 6, and 3? 12 again, right? So everybody gets a 12. Notice that I put parentheses on this one because there's going to be stuff left over, a number, to distribute. All right, so let's cancel the denominators. 4 goes into 12 3 times, 6 goes into 12 twice, and 3 goes into 12 4 times. Now in the first fraction, we're going to distribute a 3. The second fraction, not a 2, but a negative 2. Don't forget that minus sign that's in front. A lot of people will forget that minus sign. Don't let it be you. All right, so we have 3 times x minus 4 is 3x minus 12. And then negative 2 times x plus 2 is negative 2x minus 4. Hopefully you got that minus 4 there. On the right-hand side, we have a negative 2 times 4, which is negative 8. Now we will add like terms on the left side. A 3x minus 2x is simply x. And minus 12 minus 4 is negative 16. Add 16 to both sides. So x equals 8. Okay, that's it. I'll see you here for the next... Oh, I'm sorry, it's not done yet. Pretend that didn't happen. Let's keep going. Okay, last topic here. Almost forgot about this. What if the variables cancel? So you're doing your work, and the x's all cancel, and all you have is numbers. Right, so there's two possibilities. So here's our first one. If we have the same number on both sides, then the answer is all real numbers. That means any number will actually work. We also could use a symbol. It's kind of like a capital R, but on the vertical line, there's two vertical lines. Normally when you write it by hand, you just use two vertical lines. You don't have to make a double line around the R, top of the R part or the bottom of that R part. It's just two vertical lines. But I couldn't find a symbol on the computer, so that's what I put. Okay. If we have different numbers on both sides, then the answer is no solution. And then the symbol is no solution symbol, a 0 with a slash through it. So remember, if you want to put 0, then just put 0. If you put a slash through it, it means no solution. So some people have a habit of always putting a slash through their 0. In math, that's a bad idea because it might be confused with no solution. So the capital R with two vertical lines, all real numbers, and the 0 with a slash through it, no solution. Okay, last two problems here, 8 and 9. So we're going to solve this problem, distribute the 2. You might want to pause the video and work it out. Okay, so you worked it out. 10x minus 7 equals 10x minus 6 equals 10x plus 7. Subtract 10x on both sides, and here we go. We have two different numbers on each side. Negative 6 does not equal 7, does it? No. So then, therefore, we will put the answer, no solution. You can either write no solution or just a 0 with a slash through it. Okay, last problem. For reals this time? For reals? Okay. Distribute the 3. The 2 will just come straight down on the left side. So you cannot add the 2 and 3 because the 3 is being multiplied by something. So you have to finish the multiplication before you can add. Order of operations. So now if we add like terms, a 2 and a negative 12 will give you negative 10. So that gives us 3x minus 10. Now at this point, you could probably already see that we have the same thing on both sides. But if we take it one step further, subtract 3x on both sides, we get the same number on both sides. So what is our answer when we have the same number on both sides? All real numbers. So you could either write all real numbers or that capital R with two vertical lines. Some people call it a double stroke R. Okay, that's it for this video. I'll see you here for the next one. Have a good one.